Here's another very interesting model. This one is another exponential function. This is a logistic growth model. This occurs in many situations where growth starts off very rapid, but then it begins to slow down and tail off and actually approaches some limiting value or carrying capacity, the maximum amount that the model can carry or support. And that occurs at this horizontal asymptote. And you can see from looking at the equation here now, A and B are constants, and R is also a constant. It's the growth rate, but this is a negative exponent here, which means this term right here is 1 over e to the rx. And as x gets larger and larger and larger, this approaches 0. And so this whole term here, be to the negative rx, is going to approach 0. 1 plus 0 is 1. So A is this value up here of the carrying capacity. It's the value where the horizontal asymptote is going to occur. Let's look at an example of this. So here's the function again, and here's a particular logistic equation. I've put 5,000 in the numerator because let's say we have a college with 5,000 students, and the function values here represent the number of students that are infected with a virus after X days. A student has been infected and come back after vacation, and people around them are getting really sick at this, according to this logistic curve. So 5,000 is the maximum number of students that could be affected. We want to be able to use this model to answer some questions. Okay, so the first question we might want to answer is, how many students are infected after 5 days? 5 days after that sick student returns to campus and people begin falling ill. To solve this problem, now here's that function that I've graphed. The first thing we have to do is get a good window, and I don't really have any idea how long this is going to take, but tracing can help me here. I can make a guess at it. I can say, all right, X is the number of days. Let's see where we are after 30 days, after 1 month. Oh, well, after 30 days, we've already passed that turnaround point, and we're starting to level off to the asymptote. I'm going to take a stab at a window here now. For my x min, I'm going to use 0, and for my x max, I'm not going to go out to 30. Maybe I'll go to 20. And for my y min, I want to be down at 0 because I want to see the infection spread. And my y max, that's a pretty good value for y max. I know the carrying capacity of the model is 5,000. And so there it is. A logistic curve is sometimes called an S curve. S because it's sigmoidal, as I mentioned in the title, but also because it has the shape of the letter S here. And so let's see if we can answer that first question now. So we turn to our graph, and this is real easy to find using our trace command. We simply type in 5 for our x value and press enter. And that tells us that 54 students have been infected after 5 days. So that's pretty easy. The school will cancel classes when 40% or more of the student body are infected. So after how many days will this happen? Well, 40% of 5,000 is 2,000 students. So let's see how we can use our grapher. How long will it take until 2,000 students are infected? So I think the best way to answer this is going to be for me to go into my graph and put 2,000 students in there and see where those two curves intersect. Remember, we went over how you do this. It's very easy with this calculator. We analyze the graph, and we go down to number 4 here, intersection. We settle on a lower bound and an upper bound, and look, the intersection, it looks like, is after about 10 days. That's how long it's going to take. We also want to know, at what point does the growth of infection begin to slow down? And if we go back and look at this curve, this graph, that occurred somewhere along here. Right? Remember this S curve? It occurred somewhere along here, and it turns out the turnaround point is exactly halfway between the 0 and the carrying capacity. So the turnaround point is going to occur at 2,500, when 2,500 students are sick. So I'm going to go back to my 2,000 function and change to 2,500. And look, I don't even really have to do any work. The infection is going to start to slow down after about 10.5 days, just after the 2,000 point. Okay, so we can do a lot with this logistic curve, and you'll get a chance to practice some problems using this logistic growth model.